All right, so now we get to work on our last video here, which is going to be about testing the problems that you make. So what we're going to do is we'll pull up our GitHub here, and you'll want to go to right here, this /docs directory to find more documents. You'll see there's this adding your own content page here, which has a bunch of information about creating your problem. So the first thing that we have to create is this problem.json file, which the full documentation, everything that can be found or that you can include here is here. So this is just a JSON file. So it just, they give you the data types, you just format it. We'll look at a sample. And it tells you which ones are required and which ones aren't. So that's kind of nice. So you can see these are required. Pretty neat. Okay. The next thing is this challenge.py. So this challenge.py is going to be a Python script that dictates how the problem will be generated. So for example, they have a bunch of interfaces for making problems. So for example, they have a template that spins up a PHP server. And so instead of having to mess with the server, you can just call this PHP problem class and then it'll create the server for you. Then there's pip requirements. So this is just a list of things to install with pip, and then a script for installing dependencies that will be executed after installing your problem. So those are both not required. And then any other files in your problem directory will be deployed as is. So that means if you have a binary or something, or like the code you want, you would have those, and those would just get deployed as is. So what we're going to, and let me pull this up real quick. So here's the challenge.py. So it's part of this Hacksport library, which you may recognize that name as the owner of the problems in the shell server. So it has stuff like this import compiled binary. So this is a class that creates a challenge from a binary. So for example, the buffer overflow uses the compiled binary to create a challenge. So yeah, here's a nice walk down. This is a pretty good walk down of this, including like they have the service class here. So this is for things where you like need a netcat into a problem. They can have this, so you don't even have to worry about SOCAT or any of that. You just write your program and it'll do it. It'll handle all that for you. This is cool. You have the remote. Remote's also very nice, similar to that. And then Flask app, this is also extremely nice, this Flask app one. So you can spin up a Flask app, no problem at all, including a database. So that's pretty cool. PHP apps, and then here's some usage tips. So pretty great. One neat thing is the templating, so you can use that. So that's pretty cool. Let's see. So you can see here, yeah, this is neat. So just like if you've ever used Flask, so templating is something where you like commonly you would have like an HTML file and you want to fill something out. If you put in this, this is Flask format, just this double bracket notation will fill in this with a variable. So you can have this secret number. It'll actually create a random number, and then in your C code, right before it compiles the program, will actually fill this in with that random number. So that's pretty cool. So then you could have them try to guess it. And so this would require them to take the binary, reverse engineer it, and get the secret. Pretty cool. It's really neat what you can kind of do with this. So pretty also neat, pretty cool. You can do this URL for the problem. which is nice. So yeah, pretty cool. So this is useful right here. This here where they have the SQLite connect. This is how I would recommend them do it again. This is how they recommend the databases. I would also recommend we only use SQLite databases unless there's a reason we need to use another, which is nice. Here, and they give you the template both for Flask and then here for PHP. So yeah, so now you would be able to use this $data DB to access the database, and it would be from a SQLite file. So very nice that they kind of allow you to, they kind of give you that code already. So someone was thinking about doing a SQLite SQL injection attack. This is where I would start, is right here with this PHP template. Okay, so now that we've kind of walked through all the documentation they give you here, let's go through the rest of this. So the next thing is that they give you the sudo shell manager, and this allows us to test out these problem directory. So what I would recommend you do is, you probably don't want to develop in you probably don't want to develop in Vim if you're not used to it on the server. So what I would recommend is that you just, like I like to use Atom or something, you'll just spin up a, or like I have a directory here. If I go, where is it? I think it's under Documents, 2020 Cybercamp CTF under my Documents that has the Git repository. So I'm actually going to change the code. I would go to Problems. You can create, kind of put this wherever you want in here. I'm not sure. We'll see. But under probably bundles, let's go ahead. We'll do like a WC. Not sure if this is the right place for that. We'll go ahead and we'll just do a new folder for right now. Do something like this. I'll make sure this is, well, it doesn't really matter where you put them for right now, so I would just do folder, call it problems for now, and we'll work that out when we get doing the Git later during the merging. You have a problems folder, and then you can start creating your new problems here. And so this is all, as you can see, this is a Git repository right here. So you could just type all your code into here, and then when you're ready, you can use SCP to move them into the shell server. So you can use SCP as a, again, I don't want to use VMware. Let's go back to this. So this is the shell server. Let me exit real quick and log back in. Okay. So we can go ahead and you can use SCP. SCP is a command line tool for moving files, so you could use that to move them if you wanted to, or you can use something else. Like for example, SCP works just fine, but I am a bit lazier. So what I would actually do is install something like WinSCP. So let's say you're working on a problem here, and I'll just copy one of the examples for now. So you're working on this binary exploitation problem, blah, 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 blah. And if I pull up GitHub desktop, you can actually just, you can add a new site, SCP, host name, we just do 192.168.2.3, port number 22, we put in the Pico, and then the Pico shell, login, and that'll actually, perfect. So now you'll see we're actually, we have access to these files. So then what you would do is you would just come in here, you can go to your problems, and you can just drag this over wherever you want it. in here, and then test them that way, just like that. So then you make some changes, then you just copy it over, and it'll rewrite everything for you. So you can just keep doing that to kind of change things. And so you can make your changes here in your Windows machine or whatever type of machine you're using, and then you can come back and you'll see that here I have it in Git. I have that repository, the 2020 Cybercamp CTF. You can have your own branch by making a new branch here. Say, for example, we're making a buffer overflow. I would say new branch, new buffer, name it like buffer overflow challenge. And then we can do that. So that works great. And you'll see that it actually gets all this. So when I'm done, I could add all these files and then commit them to the branch. So that's pretty nice. So yeah, so now we've copied those over. You'll see here we have this problems folder. So now what we're going to do, and this is the part I haven't tested, so we're actually gonna test this out ourselves. We'll come in here to sudo shell manager install, and we're gonna run this program, sudo shell manager install binary exploitation. Okay, the problem's actually already installed. So let's go ahead and make some changes to this real quick. Okay, so we'll go ahead, we'll name it we'll name it buffer overflow 2, for example. And then let's go ahead and open this. We're actually going to leave the vuln.c code alone for right now. Close other tabs. Okay. This looks fine. We'll leave that how it is. Let's look at the JSON file. We'll go ahead and we'll just rename it to buffer overflow 2. The category will stay the same. Exploit and you can see this URL templating they're using here. You can also use the templating in the JSON files, which is very nice. You can get the URLs here. Display buffer overflow 2 found here, and then the directory there, which is again templating, and we'll change the author to Kevin Dennis, or actually we'll put K303 from USF. In the event, we'll just leave a sample right now, but we'll probably make it WCSC. Yeah, we'll change that there. We'll change the walkthrough. You need to overwrite a variable. That'll be our walkthrough. Hence, this is a classic buffer overflow with no modern protections. You need to overflow the variable. Okay, and so now we've changed this program, and this it's buffer overflow 2, so we're going to make it 100 points. So now we've changed this problem. We've created a new problem, even though really we just kind of redid a problem. So okay, so now you'll see that here. That'll show up in our GitHub that I've made these changes to this program. Wow, I have this new problem. Wow, so cool. We'll go into WinSCP. We'll just take this problems folder, copy it straight over, and now we'll go ahead, ls here, cd into the binary exploitation, cd buffer overflow 2, and you'll see that that's now there. It's pretty cool. We have that going. And we'll just, if you do it on the binary exploitation or the problems folder, it'll try to install all of the problems. It'll go down into each folder and install every problem. So buffer overflow 1's already installed, so we're just going to do sudo shell manager install, and we'll just do buffer overflow 2. Okay. File size limit exceeded. Uh-oh. Okay, so that's something we need to change real quick. Let me look up how to do that. That's something we want to change in general. All right, so I had to look real quick and remember what I needed to change to do that. So one of the things that they change when you do the Ansible on the shell script is they limit the file size that competitors are allowed to create. Unfortunately, this means that they also limit ours. I think our account is supposed to not be one of those accounts, but for some reason it does get caught up into one of the limited groups. So what we're going to do is we'll go ahead and just, we're going to limit, or we're going to edit the limits file. So you can just type nano/etc/security/limits.conf, limits configuration. And we're just going to come down in here, and right before it starts the competitors, we're going to, and I mean, this is all very good that they have that. We're going to add Pico, and we'll keep it the same structure. We're just going to add a new thing here that says our file sizes are allowed to be unlimited. Okay. Okay, you got to do that as sudo. My bad. So we're going to do that again. Okay. So right here, we'll just put Pico dash F size unlimited. Perfect. Save it. Okay. So now we'll go ahead and do this. Did I miss it? We'll install this, and it should work this time. Okay, we're going to need to reinstall because technically the install happened. Install dash reinstall. Uh-oh, file size limit still. Maybe I need to exit and reload. Okay. We'll get there. Eventually. Perfect. Okay. Perfect. All right, so now we have a new problem loaded. So now what we're going to do is we'll go see what's next. So that actually installs the problem, right? Okay, so let's see what they have to say about that. Okay, so then we'll do this command here to find the name assigned to our installed problem. So sudo shell manager status. You see buffer overflow 2. Here is the problem name right here. This installed problem. Very cool, very cool. There are 0 instances running. Note that right here. Very important. So we have the problem installed, but it's not actually running yet, okay? So now what we're going to do is we're going to use this sudo shell manager deploy -d and then the problem name, okay? So the problem name again is going to be this here. So sudo shell manager deploy -d and then the problem name. So what this -d is going to do is it's going to deploy the problem, but not actually run anything yet. It's just going to create the directories so we can make sure that everything was set up correctly. Okay, and that's what the documentation here tells you to do. This will generate a test instance of the problem. This test instance will not have any running services, but all of the files will be generated and placed in a temporary directory. Okay, cool. To deploy it, you would then do, you would just take off that -d tag, and then you can test it running. So there's also some pretty neat things here. We have our like -in parameter to specify the number, and stuff like that. Okay, so we can see here, test instance 0 information, description, exploit the, you can see the thing was completely filled out here. If you remember, that was our templating, but this is pretty cool. You can see the templated results. It has the, here's the URL for the file. And then it has the location. Here we have our deployment directory. So this is our staging. So now we can copy this. We can ls and look at that directory. Okay. So this needs to be a string because there's a space in the file name. And then you need to sudo it. but you'll actually see. So this is what it would look like if we had actually deployed this problem. So you can see that there's a flag.txt file and a vuln file. So it's exactly how we wanted this to be set up. If you remember from the buffer overflow problem that we looked up in the past, that's how it was set up. It had a flag and then the executable that was going to be run. Okay, so that's perfect. That's exactly what we want. So now that we know it's working, let's go ahead. We'll run status again. You'll see that there's still no deployment. So now what we'll do is we'll go ahead and we'll deploy it. And let's say this is a pretty popular challenge. We'll go ahead and deploy 3 instances of this. That way we can really make sure that people don't cheat. Okay, so you see problem instances 0, 1, and 2 were successfully deployed. We'll run this, and we'll see that there are now 3 instances running. Okay, great. Let's go look at that on the web. Okay, so here are our list of problems. Now that's weird. We have SQL injection 1, buffer overflow 1, and ECB 1. So our problems don't actually show up until we enable them. We have to go in. Well, first, that's not even going to be listed, right? We need to go over to our shell server and then load deployment like we talked about before in the last video. So that'll load all the new information about all the new problems that are now available, right? So successfully loaded problems. Now if we go back to manage problems, you'll see that buffer overflow 2 is now here and it is disabled, right? If we go back to the list of problems here, it's not here. Ta-da, not there. So we need to go back to the admin management and go ahead and hit enable. Hit enable. There we go. And now when we refresh here, you'll see buffer overflow 2 is here. And it's got our new hints. There is a classic buffer overflow with no modern protections. You need to overflow the variable. Very cool. And then if we go back to the management and we click on the problem, you'll actually see like some of the other stuff loaded in here, like the instances and flags. And then this like K-Trio3 at USF as the author. So pretty cool. So that is how you load the problem, you test it. So you'll want to kind of write your problem in your Git repository, however you want, in whatever editor you want. Go ahead and create those files, just like in your Git repository. Then when you're done, you'll take that whole folder containing the problem and just use something like WinSCP, just stick it in your home directory. Maybe you just have a whole folder called problems. You just copy that over with your changed files. Then you navigate there and you run through this just like we did, and you'll be good to go. And you can test your problems out. Make sure everything's working correctly. Okay, so that's pretty cool. So that'll kind of conclude the video. One thing I'll be pushing up, I'll try to branch this out sooner rather than later, is in the, let me pull it up real quick. In the 2020 Cybercamp CTF, if we go back to the PicoCTF shell, there is the that's where it goes, right? That's where it went. Oops. Oh, where's that code? 1 second, let me find this real quick. Thought it was in here. Ah, here it is. Yeah, it's under here. It's under this problem. Okay, so I was looking straight at it. So if we look at this problem class, the challenge here, it has this generate flag function. So that generates a flag using a random like hex digest. One of the first things I'm going to do when I push up to Git is I'm actually going to change that to be basically it'll just be return something like return WCSC. We'll make that all caps. WCSC plus, and then a closing bracket, just like that, so that our problems now look like that. So that would require for us to kind of reinstall these this Hacksport library with these templates. So I'll have instructions on how to do that later once I actually make this change and have it tested it out and make sure it's working. So yeah. So one thing is kind of neat. If you want to, let's say you don't like the just having a random token as a flag, which I kind of don't like either. You want to make it something, funny. You can, when you declare your function that inherits from challenge, you can redeclare this generate flag. And so what I'm going to ask is that when you do that, you can make the flag. So you can make the flag something like return WCSE, and then you'll want to fill in, like, let's say you wanted the flag to be, wow, that was a cool challenge, right? We'll do something like that. And then after that, you would have in this hash, like an underscore, and then hash token. So every flag needs to have some kind of randomized part to it. But if you want to have it have a personalized bit in the beginning, you just overwrite this generate flag. So I think I would really prefer it if most of our challenges did do that. But if there's a reason why not, let me know. But yeah. So if you have challenges like pictures, like steganography challenges, unless you write a script to inject the flag into the file, probably won't have flags like this, and that's totally okay. But for challenges that can use this kind of file and be automated, have automated flags, this would definitely be the preferred way, is something like this. So, okay. So that'll be the end of the video. If you have any questions about this, let me know. I know it's a lot. But yeah, if you successfully get some kind of challenges out of this, I'll say you've learned a lot at this point if you get this up and running and then write some challenges in this. So I mean, what have we used? We've used Git, Ansible, VirtualBox. We're using Ubuntu Server. You've touched things like you had to change the configuration limits folder or file to allow you to write files of an unlimited size. You're using SCP and SSH to test test programs in a test environment. Lots of crazy stuff like that. So, and this is an open source project, so technically you've contributed to open source development. So congratulations. So yeah. So please let me know if you have any questions. Yeah. Cool.